Okay, thank you, David. Before I start, I want to note that the methods presented today are not a recommendation or endorsement from my employer. So where does CO2 come from in a classroom? Your lungs exchange oxygen in air with carbon dioxide. And importantly, the amount of carbon dioxide that we emit depends on our age, activity, and our size. The air we breathe in is about 0.04% carbon dioxide, and the air we breathe out is about 4% carbon dioxide. Given this relatively high concentration compared to other chemicals and emissions from people, carbon dioxide is a good proxy for emissions from humans. In fact, we can use it to determine the fraction of air you breathe in that has been in other people's lungs. For instance, if the indoor carbon dioxide concentration is 2,000 ppm, or 2,000 carbon dioxide molecules per 1 million total air molecules, and the outside concentration is 420 ppm, then 4% of every breath a person takes in a room will consist of air that's been in somebody's lungs. For airborne viruses, we want to keep that rebreathed fraction and carbon dioxide concentration as low as possible. If we want to use CO2 as a carbon dioxide as a ventilation fluid, we need to make sure that there are no non-human sources that are going to impact the concentration, such as indoor combustion or vehicles idling outside indoor air tanks. In addition, it's also important to note that CO2 is only a proxy for human emissions and does not account for many other things that impact our indoor air quality. If we want to use consumer-grade CO2 monitors, we need to make sure that we understand they have limitations. Monitors using NDIR sensors can have errors non-NDIR sensors can have errors depending on their calibration chemical. Although NDIR sensors report values to 3 significant digits, they're only accurate to about 50 ppm. Finally, all of these sensors can drift over time. So it's important that we measure the difference between indoor and outdoor CO2 concentrations, as that gives us the most accurate and reliable data that we can use. To use CO2 sensors to check ventilation, we need to place the sensor outside for 5 minutes. Make sure the room to be measured is occupied with normal occupants and use patterns, but has no non-human CO2 sources. Locate the sensor in the middle of the room and log the data for a full day. Ventilation changes dependent upon the windows, operation, season, weather, and HVAC operation. So we need to repeat this measurement on a regular schedule. Carbon dioxide concentrations build up in a classroom over time. This is why you can't just take one measurement at one point during the day. Rather, it needs to be logged for the entire day. In this case, you can see when kids entered a room, went out for recess, and the peak concentration, all of which would give very different single point readings. The data of interest for us here is the highest average value over approximately 15 minutes. In this case, it's about 1,200 ppm or about 800 ppm above the outside concentration. The power of the CO2 monitor is that in this portable classroom, the CO2 concentration was about 2,100 ppm the day before the teacher was given a CO2 monitor. They were able to actively open windows and doors to reduce the CO2 concentration by 900 ppm. ASHRAE is the North American Standard Organization for operating buildings, and it provides standard values that classrooms should be ventilated at in pre-pandemic times. In this case, ASHRAE recommends that ventilation for classrooms with 5 to 8-year-olds that is typically would result in CO2 concentrations that are about 550 ppm above outside concentrations, or 970 ppm. This air change rate is roughly about 2.6 for an average size classroom. Pre-pandemic studies have shown that most classrooms are not ventilated to these standards and typically have higher CO2 concentrations. Since the pandemic, several organizations have suggested roughly doubling the effective ventilation rate in classrooms to 15 liters per second per person, and this would result in concentrations that are about 400 to 500 ppm above the outside concentrations, or result in effective air change rates of about 5 to 6 per hour. The bottom line is that CO2 concentrations vary with time, room, season, and weather pattern. A single measurement from a few minutes is unlikely to capture the dynamic ranges or give actionable data. High CO2 measurements do not necessarily mean there is a risk, and low CO2 values do not also signify that a space is safe, only that it's safer. Finally, CO2 monitoring of ventilation is but one component of overall risk reduction strategy to move viruses from airs that includes portable air cleaners and HVAC filtration.